Okay, I've got sound here, so I'm going to come over as I had promised you guys on Wednesday. I'm going to do an extra recording from Wednesday covering this case out of DataSmart, and and this is the outliers case, and this is the one over from Chapter 9. Okay, and so I want to pop over there. And again, this is I'd spoken with you Monday. Pardon me. Yeah, no, but pardon me. Yeah, Wednesday. Okay, yeah, that was the pre-recorded one for identifying outliers, and that's what we're going to do. Okay, and so we'll talk about that now. As I mentioned before, all right, that starts over on page 335 in Chapter 9. Okay, and well, really, he talks about Tuckey fences and applying them in a spreadsheet. It's really actually page 341. That's where the case starts. And this is the one dealing with outliers. So we're going to go over and get that we're going to go over and get that file, okay? And let's go over into the files section. And we're going to come into the Foreman files, and we'll find those. And we'll download those. That's the zip file with the Foreman files in it. Okay. And I'm going to show it in the folder. I think. Or I thought for sure I was. There it is. And I'm going to open it up. It's Chapter 9. We'll open that up. And we want the support center file. So I'm going to put it down here. I'll copy and replace it. I already have it there. So, okay, we're going to work with the support center file. And we get that over from the files area. And I'll scroll back here. All right. And this is, again, this is the supplemental, or pardon me, the second screencast, okay, that for Wednesday, November 1st. So I'm going to call it screencast number 2 for November 1st when I'm through recording. And I'm recording it here, as you can see. Okay. Now I'm going to open up that support center file, and we're going to walk through some of the tabs. Now, I want to make sure that you remember that when you go in there, you're going to see that I've created a couple of PDFs that explain to you how this is all put together, explains to you the Excel functions that are used, and how the case is handled. So I'm going to diminish this down for a moment, and I'm going to go down here to the module, okay, and where you'll find it. And here it is, Support Center Part 1, Support Center Part 2. Both of these are PDFs, okay, that will show you how this thing's put together. Now I'm going to refer to them. Now you can also follow along in the Foreman text as he does this and walks us through it, or you could download these two PDFs and watch. Also provided you a p-value, because at the end of this we're going to compute a z-score, okay, and z-scores are can be approximated from a probability basis. And remember, we talked about this when we talked about, you know, a Gaussian curve, and the fact that the Gaussian curve, that be one standard deviation above the mean, one standard deviation below the mean. There's about 68% of all observations fall within that. Then between 2 standard deviations above and below the mean, you have about 96%. So it's a mirror of 34, 14, and 2 on the right-hand side of the mean or above the mean, and then it's 34, 14, and 2 to the left or the lower than the mean. And so we're going to compute some z-scores, and then we're going to say, okay, what's the probability I would obtain this z-score, assuming that I have a normally distributed set of data. So in this case, unlike the case where we did the cluster analysis, okay, what we're doing here is we're looking at outliers, stuff that's away from where all the scores and everything tends to cluster. And of course, this is due, the outliers, it's due on the 3rd, and that's Support Center and Hammondsport. We talked about that as well. That's due on the 3rd, and Chapter 11, and that's on the 3rd. Then we talked about, I've got some resources here for you that deal with waiting lines, okay, and the return on investment that we get using analytics. Well, that being said, I'm going to finish off this. Now, I'm probably going to do 30 or 40 minutes here, okay, on this. And so you'll have had, this would be part 2. So you'll have had about an hour and a half or so worth of time spent looking at this outliers file. Now, let me say this again, or reiterate, or reemphasize is probably the best term. Look, this guy is absolutely off the charts in terms of smart, okay? And he really shows us some beautiful models to analyze data, okay? Some we analyzed some tweets, which are in structured data, and built a predictive model, okay? We're looking at scores here, just simple count data, okay? When we did the cluster analysis, we took a couple of variables to see if there were clusters or market segments. So you know, not too bad. And again, I wanted to make sure that you don't lose this, because this is really, really good stuff. And as I want to say again, Chapter 1 of this book is one of the best chapters on using spreadsheets, and most importantly, developing your own functions in a spreadsheet I've ever seen in my life. It's excellent stuff. Well, I'm going to open up the Support Center file, okay, and we're in here. And it's just, we're at the tab. And again, we've got these employee ID, the average tickets they do a day, the customer rating, tardy, graveyard shifts, weekend shifts, sick days taken, percent on Friday, employee development hours, shift swaps requested and offered. So we're looking at some, if I were saying, okay, what type of table is this? I'd say this is really a fact table, if you will, okay, for the simple reason it just lists facts, okay? And so it's not a production table, because it doesn't, I guess you could say it is because of the daily tickets. Those are transactions and customer ratings, but I don't know about that. I think it's more of like just a fact table, okay? But you can see the dimensions here. But what's going on here is the question is this is an employee who does their share of work, is on time. Are they willing to work at weekends if necessary? Do they max out on sick days, or do they really take days when they need them? How many times is it that they've done that and lumped it into a Friday? And then if someone said, could you swap shifts with me? I've got to take my kids to the doctor or whatever. How many times that happened? And then how much have they invested in themselves employee development hours? So this is really, we're looking at somebody, are they a team player? Are they fitting in? Are they working hard? That type of thing. Okay. Let me say this. This is what I like about this case is this is very typical of the stuff you'll see out there in employee evaluations. Okay. And again, these are fairly decent metrics, but do they as a whole tell you something? I don't know. Okay. But we're going to take a look. Now, let's look at the average ticket for a moment. All right. And here it's 151. And let's scroll all the way down. Okay. If I'm not mistaken, there are 400 entries here. And for each person, okay, well, we have some aggregate data. Excuse me. We have the mean in terms of average. We have a mean in terms of average number of tickets, customer rating, tardies, shifts taken. These are all count data. Okay, and then we have the standard deviation. And then for each of these categories. Now, as I said before, I went on a rant the other day about the fact that this is the mean number and standard deviation, kind of sketchy here for the simple reason that, for the very simple reason that if you have counts, if these are nominal data, okay, then they should simply, you shouldn't have these like a 168.7, but you know, we'll cut that corner, and so we're in good shape. Now, the next thing we're going to do here in this second tab is we're going to standardize these data. Now, I'm going to click on the formula on the dialog box for the function box, and when we standardize data, okay, we put them within some kind of distribution so that they're standard. We clean them up a little bit, just like we use ratios to clean up data. Counting ratios is a good example of that. So here in the standardized, we've got the support personnel. That's got that exclamation point, meaning that tab, and it's B2, okay? And then the mean, we computed the mean, okay? And then we computed also, we used the standard deviation, okay? Notice this is all, and now we're able to compute a standard score. And in this case, we get a standard score of minus 0.97, okay? So this one's, the standardized score is a little bit below, okay, the mean. All right. Now, we're going to, and we do this for every single employee, and we do this on every single measure. And you can just see it. So we standardize them. Now, in the PDFs, okay, what we're doing is we're normalizing the distribution. So when I say, okay, we're cleaning the data up a little bit, I mean normalize technically. And we do that by using the mean, okay, and then using the standard deviation. And by normalize, what that means is we put them within the parameters of a normal curve, i.e. a Gaussian distribution, if you will. Okay, and that's what's going on, because we're going to assume that these are normal. These are distributed normally. So we compute the standardized for each of them. We'll come down here. I can't remember, there were 400, and I think 408 or 409 employees, or 400, excuse me. Oh, we got their standardized scores. And I talk about that there, and then remember, I have two PDFs that you would be wise, if you really want to grasp this, to see what he's done. Now, the beauty of this is he's using some pretty simple Excel functions and statistical functions, all right, but doing a nice analysis. Now, there on page 343, okay, and you'll want to take a look at that. Foreman explains what it means to standardize data, okay? And then he talks about computing a z-score. And the z-score is where we take the observation minus the mean and divide that by the standard deviation, okay? And that's our z-score. And you certainly, I'm certain you had z-scores in stat. Well, let's click on the distances, all right? And what we do now is we start to, he creates a function whereby we can compute the distance between one employee versus another. Now you'll notice, for example, and I'm on the distances in this array. I'm at C3, and so basically I'm starting at employee 0 and I'm comparing them against each other, and of course there'll be 0. And you'll notice there's a diagonal as it comes down through that array. Now he's created a function here by using the brackets, okay, and remember, now we talked about the distributions, and I'm going to walk you through, okay, what he's doing there. First of all, he's using a square root function, okay, we understand what that is, of the sum, and then we identify the cell, and we use the offset, okay, the offset function. Okay, so we've got we have a square root, okay, which is embedded in the brackets. Then we have a sum, which is the first parenthesis to the left. Then we have the offset, okay? And the offset is basically we have the anchor cell and the number of rows and the number of columns. So we place it. We look at the offset, okay? And for example, A3 in the formula, A3 refers to A3 in the distances tab. It's 0, and it says advance 0 rows. And then another 0 means 0 columns to the left or the right. So in the end, in cell C3, we compare it against itself. Now in D3, it's different. We compare employee 144,624 versus employee 142,619. And we get this distance. Now, remember, we talked about using models in science, in management science. We use models, okay? And here we're using Euclidean distance, all right? You remember when we did the cluster analysis, we used Euclidean distance to see what are their clusters. In fact, we even said let's build a fifth, see if we can identify a fifth cluster. And when we compared, okay, the output score in terms of distances, we didn't get that much. So for five clusters, we're not going to do us much good. So and there in that PDF, I walk you through that, okay. And we're using the Euclidean distance to compute the distances. We're using that. This is again what we do in management science. We find a model that applies, okay, and we use it. And we have employee 144,624 compared against everybody. And they do the same thing for employee number 1, who's 142,619, etc. Okay, and he's created that function. This is similar to the cluster analysis. Okay. But now we're looking not for how well things cluster, but we're looking for distance, and we have that. Now I'm here on row 3, and I'm going to scroll all the way across. You can see we got a lot. And we get this one value. Now, let's look at this for just a minute, okay? And we get these distance scores, okay? Now, the next thing we're going to do is rank these distances. We computed the distance, so they're raw data, okay? And you can see this one employee has some serious distances. And the next thing we're going to do is we're going to look at the ranking. And we have all of those laid out there. Now, the rank uses the rank function here, and that's the number. That's the number you want to rank, the value, the reference, or the reference. You'll have an array or a reference set to a list of numbers, and then the order. And if it's 0, it's omitted, and a descending order occurs. If it's a non-zero value, it creates an ascending order rank. If you duplicate numbers, get you the same rank, or you can use a correction to handle ties, which is what they do. They made that -1 here in this formula is a correction to take care of any ties in the ranking. So we're ranking them on the basis of their distance. And obviously, the larger the distance or the bigger the difference, the more that is an outlier. Then we do the k-distances. That doesn't sound familiar to you. It should. Remember, we use those. And we're looking at how many employees are in my neighborhood. okay, or within my distance, okay. And here's this first employee, 144624, that has 2.9, basically 3 employees in their neighborhood. Now, obviously, the bigger these get, the bigger the K distance, the bigger they are, okay, the more they're more of an outlier, okay. And the rank shows us the results of comparing the ID to itself, and then, and again, it starts with this. The rank equals it's a sum function. We have that within the brackets. Then it's the distances. That's the number of the rank. Okay. Then the reference array. Okay. So we have the distances. That's the distances tab. Then we have the number that we're going to rank. Then we have the distances array, and that's C3 to OL3. And we have that -1 that gives us self distance, and it's a rank of a 0 rather than 1. We have that corrected built in. Okay. And I'll walk you through each of those ranks, what they show. And what we did then is we went ahead and we used conditional formatting, okay, to put these into perspective. Now we could map them. We could graph them if we wanted to, but we did the simplest thing. Now, if we're interested, you can click on conditional formatting, and we can click on manage rules, and it will tell us. Okay. Click here. And we're using a thermal. And we'll click edit the rule. And we want the lowest value, highest value. And we're using, white is the lowest value, red is the highest value. Okay? And we have, of course, those in between. So we have that gradient, okay, or what I call a thermal, that gives us that picture of the K distance between them. We talked about and used that before. Now I'll walk you through step by step by step, okay? And then we move over to the reach distance. We use the K distance for each of those employees. And we find the maximum. This is over in the reach distance. What's their maximum for each employee? What's the maximum distance? The K distance tells me what's the difference between that employee and their neighbor. And we're computing everybody's distance to their 5th neighbor. And in that K distance, we're looking at, you're using an if, and we rank it. And I'm right here in the cell B, should be up here. Let's go to cell B2, B4, excuse me. And I'm just getting the K distance, and I'm using if, and then we're going to sum it if it meets the condition, it has a rank. Then we have the criterion, which is B1. And we set the value to 1. It's in a vector of 0. Then we take that times their distance as score, and that array is C3 to OL3. So we compute a K distance, and we've done this before. And he talks about this. Talks about that there in the text. Now, And if you want to see, not from my notes, okay, but I'm going to pop over here to where he talks about K distances, okay. And that starts over page 351, okay, and that will refresh your memory. So now we're going to look at the reach distance, and we look for the maximum number in that distances tab. And finally, we're going to compute a local outlier factor. And again, we have another one of these sum ifs. We rank them, and then we use colors. We use a thermal conditional formatting to put them into perspective. And the darker it is, the greater the local outlier factor. And you can see the equation there, and I'll leave it to you to read through, because this is an excellent, excellent tool, again, and we identify those employees who are local outlier factors. Now, you say, well, why would you use a thermal here? Why don't you just go ahead and copy them in, okay, and get the go ahead and copy them in and use, okay, that and just put them in order, which we could do. Now here's the average reachability, okay, and over on page 353, you'll want to take a look at that, because he really shows you how K distance, he illustrates to you how K distance works, okay? And it's the distance from an employee to their Kth neighbor, in this case, their fifth neighbor. He could have done for the fourth or fifth or sixth. And he shows us the skeletons of those different tabs. I also show you that whole concept, okay? And again, that's really about all there is to it. Lots of detail in here, so if you really wanted to put your, sink your teeth into this and read it bit by bit, you could. But here, basically, we've got a local outlier factor, okay? And the larger it is, the average distance from their neighbors, and of course people are way far from their neighbors, are the outliers. And he's going to show you that. He shows you that concept over there on figure 917 over page 354, as well as figure 916, okay, in terms of local outlier factors, and trying to find out how far away they are from their neighbors. Okay? Now, I want to stop for just a second, and I want to help us put this into value, into perspective, because we basically compute some z-scores here, okay? And z-scores, as I said before, are probability functions. And for example, if the z-score is 2.35, okay, we want to know what's the significance of it at the 0.05 level. And when we say one tail, we're talking about one tail or one side of the normal curve. We're going to say a two-tailed test, and I'll calculate, and it'll tell, and what it says is the p-value is 0.018. So there's about a 2% chance that you would get this type of z-score using a two-tailed test, and that you're looking at both sides, the right and the left, of the mean. You could do a one-tail test. Let's see what it looks like if we do it at a one-tail test. And we can see the significance of it drops tremendously. It becomes 0.9%. Okay? So you will see this as you put in z-scores, you'll see this phenomenon occur. So that's pretty much it as far as that case. That would be part 2. And that'll wrap it up for this week. And just real quickly, I want to make sure that I'll add this second one to the announcements after I finish the recording and post it. I want to go over here quickly to the syllabus and make sure we all know what's going on, what's due, okay, and what's coming up on November the 3rd. You have Chapter 11 exam. Then you have the Hammondsport 1 and the outliers. Those are due. And that's pretty much it for this week. Okay? Well, folks, I will see you all on Monday, and we'll do some work again then. And I think, if I'm not mistaken, this is the last case that we do out of the Foreman text. But it's just a very, very, very well-designed and executed use of functions in Excel, statistical theory, and we've traveled some pretty heavy-duty material here, and I know that, okay? But I wanted to let you see what data scientists are doing and management science people are doing right now with some of the newer tools and a lot of the what we would call unstructured data that's out there, okay? That'll pretty much do it. And folks, I'll see you Monday. I'm going to stop the share, and then I'm going to stop the recording and end the meeting.